we started last week with 45, 45, 90 triangles. So when we use, like on our quiz, the Pythagorean theorem, we have two sides. When we have special rights, we don't have, I'm only given this side of my triangle. So even if I wanted to use the Pythagorean theorem, I can't, because I don't have, to use the Pythagorean theorem, I need 2 out of 3 sides. I have 1 side. Okay, so I have to know, and we'll talk about how you can maybe, I won't call it a cheat, but you could use the Pythagorean theorem if you get stuck on one side with a special right. If you can somehow get one other side and you get stuck, you could always switch to the Pythagorean theorem, but that's a little bit, I feel a little bit more stressful. So instead, we learn that our special rights always have this relationship. So for 45, 45, 90s, these, it's also important to note, are the legs, and this is my hypotenuse. Okay, so it always has to be that way when I'm labeling. What I do is I just go ahead and label this pattern around the outside of my triangle. So I'm really kind of ignoring these variables that are here. I know I have to solve for these two sides, but here are my legs, because my hypotenuse is across from my 90-degree angle. So my legs are, I'm going to call X and X. And the side that I have is my hypotenuse side. I actually don't want to start with this one now that I started it. I don't like this one as our first one to look at. Okay, but in terms of this pattern, labeling this first triangle, here are my legs, here's my hypotenuse, always this pattern when it's 45, 45, 90. Let's start with an easier one. Let's start with, two's a little bit easier, still not as easy as the first day we did this. So here, which side is my hypotenuse? Here, N or M? Which one is the hypotenuse? M. So labeling this, I'm going to go X, X, X rad 2 where my hypotenuse is. When I solve for my sides of my special right, the first thing I need to do is always determine what X is on its own, and then I just substitute X in to solve for the missing sides. Okay, so for this particular setup, I'm given what X is. Okay, X is 5 rad 2 over 2. It gives me a side that is in side X. So I know X is 5 rad 2 over 2. And I'm going to substitute X into this pattern all the way around my triangle. So on this side, it's again just X. These two, on my 45, 45, my two legs are always the exact same value. So this side is also 5 rad 2 over 2. Just substituting in X. X is this, okay, this side is just X, it's that. Where it gets tricky is when we get to a side like this. So this side is X rad 2. I know that X is 5 rad 2 over 2. All I did from here to here was take, I know this side is X rad 2, and I know X is this. So I substituted in. And then what happens with the arithmetic here is that this rad 2 is over 1. So I'm getting, and I can multiply numbers that are outside together or multiply numbers that are inside the rad together. So I can multiply these two terms together. It gives me 5 rad 4 over 2 times 1, which is 2. Well, the square root of 4 is just 2. So I'm going to get 10 halves, which reduces to 5. This side is equal to 5. Okay, X rad 2, clean it up, is 5. Okay, so I have to do this work afterwards. And that's the tricky piece here. So now I'm going to go to 4 actually, and then we'll do 1 and 3 last. So on 4, I again label X, X, X rad 2. So notice I'm totally ignoring this Y and that X. And if you want to totally get rid of them, that's fine. Just know that you have to find all of your sides. in the x. I'm just kind of ignoring the other variables that the problem gives me. I'm again given x. X is 3 rad 6 over 2. So now I'll go around the other two sides and substitute this in. So this side is just x, so it's 3 rad 6 over 2. This side is x times rad 2, so x is 3 rad 6 over 2 times rad 2. That's what I need to do to figure out what this hypotenuse length is. Take x and multiply it by rad 2, which is rad 2 over 1. Multiplying what's inside the rads is 3 rad 12 over 2, 2 times 1. Can I simplify the square root of 12? Can I simplify the square root of 12? Is there a perfect square number that goes into it? 4. 12 is 4 times 3, so this is going to become 3 times 2 rad 3 over 2. So now I can keep going and write that as 6 rad 3 over 2 and reduce, or if I have the same number in the numerator as I do in the denominator, I can also like cross out at this step and say, okay, those 2's would cancel and it would just leave me with 3 rad 3. So this missing side here is 3 rad 3, solving for the other side of my triangle. That's what happens when I take x and multiply it by rad 2. Yeah, Connor?
Do you always cross out the x and the y? Like, you know, you cross out.
Yeah, I mean, you don't have to, you can leave them there, but you're basically ignoring them. Like you have to find both those x and y's that are on there, you have to find both sides, but sometimes it confuses students because these are different x's that we're talking about. This is just the pattern around the outside. So if you don't want to look at them, don't look at them. Just find the two sides. I could have done this up above as well, just to kind of show you. I didn't, because I didn't want to throw too much at you in the very first example. Like here, I could have also canceled out those 2's. Anything that's in the numerator and the denominator would cancel, and it would have brought me right to 5, instead of going to 10 halves and then to 5. Okay, just a faster way to do the same work. Okay, so now let's look at the other ones. So what's trickier on the other ones is it gives us the hypotenuse instead of a leg, which means, so x rad 2, which means it doesn't give me x. Like it's not just giving me x, it's giving me a side that is x rad 2. So the side that's x rad 2 is equal to 4 rad 3. So I don't have just x to plug in to the other sides right now. I need to solve for x. And how would I solve for x? How would I get x by itself? Right now I have x times the square root of 2. What's the inverse of multiplying by the square root of 2? What's the opposite of multiplication? Division. So I'm going to divide by rad 2 on both sides. Now, why am I doing this? Well, that's because, let me switch up here. Step 1 is I got to figure out what x is on its own. Then I can substitute it in. So what I'm doing here, which I didn't have to do on the other examples, is first figuring out what x is equal to. That's what I'm doing in that step because I need that to plug into the other two sides. The issue we run into with this is we can't have a radical in the denominator. We need to rationalize this. And so we learned this in Algebra 1, that to get this not a rad, I multiply by this rad 2 in both the numerator and the denominator. So math-wise, this isn't a legal answer. 4 rad 3 over rad 2, we can't leave. So to get rid of this rad, we multiply top and bottom by it, which would give me 4 rad 6, 3 times 2, over rad 2 times rad 2 would give me rad 4, which the square root of 4 is just 2. So it gets rid of my rad, or what I would say in algebra class is rad 2 times rad 2 is regular 2. Rad 3 times rad 3 is regular 3. Rad 5 times rad 5 is regular 5. It always is going to do this. When you take a rad and multiply it by itself, it's going to get rid of the rad. And now I can reduce, so just like I can multiply numbers that are in, or I can multiply numbers that are both out, I can reduce numbers that are either both outside of radicals, or I could reduce numbers that are both inside if that was a possibility. But I can reduce this 4 over 2 to, I don't need to write x again, to just be 2. And so then I have 2 rad 6. So x equals 2 rad 6. We had to go through that. We didn't have to go through it on the other 2 examples. But here we had to solve for x. And now I'm just going to plug in, which thankfully now both sides are just x. So that means this side's 2 rad 6 and this side's 2 rad 6. There's no kind of plugging in and having to solve. I'm just plugging in. 2 rad 6 here, 2 rad 6 there. Plugging in for x. So same thing happens on 1. I've already drawn in here, my hypotenuse is here. I'm given the x rad 2 side, it equals 8. I need to find what x is. So I need to divide by rad 2, just like last time. But when I do that, just like last time, I have a radical in the denominator. So I need to multiply by rad 2 over rad 2, which will give me 8 rad 2 over rad 2 times rad 2 regular 2. And then again, I can reduce here. 8 halves is 4. Because I'm given the hypotenuse, I need to first solve for x. And now I just plug in. So this side is x, x is 4 rad 2. The other side is x, x is 4 rad 2. When you're solving a 45, 45, 90, you should recognize that every single time the legs are exactly the same and the hypotenuse is going to be different. It's not the same with 30, 60, 90s, but like that's, if you have a 45, 45, 90 and you have 3 different sides, you're not solving that 45, 45, 90 correctly. Okay? So now let's go to homework. We had homework 37 due for today. I'm not going to kind of talk through each of these. I'm going to start filling some of them in, and then we'll do some of the harder ones together. This would be 8 rad 2, 3 rad 2 over 2. 3 rad 2 and 2. So these are 45, 45, 90s that you were just solving. And I'm just filling in answers for the top 4 right now. So if you have completed this, you can check your work. And if I get to one that looks really tricky, we'll look at that together. I'm going to keep 7 to look at. And every single time, so I didn't write them out, I'm doing it in my head, but I'm using that relationship, x, x, this is x rad 2, so 8, 8, 8 rad 2. X, x, x rad 2, which simplifies down to just regular 2. X, x, x rad 2, x, x, x rad 2. Okay, I'm using that ratio, but I'm just solving for my sides using that. I'm going to move it down. And I'm gonna move this down to the bottom. We'll do 7 together. I want to pass out to you the checkouts that you have, which is linked to that first quiz, but I have some work to pass that. You know, we did on that checkout. You passed this in late. I don't have it printed and the grade on it. Those are the ones I have hard copies of. Okay, so now just looking at 7. 7 again, I like this one because we haven't seen one quite like this yet. Here's my hypotenuse, so this is my x rad 2 side, xx. This gives me, this one's actually an easy solve in terms of, it gives me a side that's not x, but I don't have as much work when it's equal to a number times rad 2. I'm just dividing out rad 2, and I want you to make sure you know you can just cancel. Just like on when it was an integer, if I have the same term in the numerator as I do in the denominator, it just cancels. So finding x here, x is just 10. So now I plug that in to my 2 missing sides. Okay. Okay. So there's more than one type of special right triangles. Our 45, 45, 90 triangle, we actually looked at a square, cut it in half, and figured out why that is. We're going to look at our second special right today, which is 30, 60, 90. So in your notes, if you can find notes number 5. Anyone need new notes for this unit? It starts with, let me just, in the front is a calendar. It says unit 8, calendar, probably in front of here. Hold on a second. Yeah.
Where is it touch mark?
No, because I was waiting for some of the online ones to get submitted. So I still have a couple I need to print out from online. But I do plan on doing it today. Hopefully they'll all be done today because I'm going to grade these and the tests. So you should see them in there either today or tomorrow. Okay, so what we have here to kind of discover what our other special right is an equilateral triangle. You see they're marked that all 3 sides are the same length, which means equilateral triangles, all of these angles are 60. This isn't a right triangle right now. It's equilateral, equal angular triangle. Okay, all of our angles are 60. I'm going to call all of these sides, they're all the same length, but I'm going to call them 2x. So if this side is 2x, this side is 2x, this length is 2x. Okay, so they all have the same length. Calling it 2x because I know where we're going, so I'm going to call it 2x. I'm going to take and drop in a perpendicular bisector here, okay, where I'm creating a 90-degree angle perpendicular. And it's bisecting this side and my angle here. So if it cut 2x in half, then how much is each of these lengths? If I take 2x and I cut it in half, I'm left with 1x. So that means this side's x and this side's x. I took 2x and I broke it apart. Okay. And if I broke 60 in half, then that means that this angle here is 30. And for this work, we're going to just be looking at this half of the triangle now. So I'm looking over here. Okay, so I have 60 degrees here, 30 here, 90 here. The side across from 30 is x. Across from 30 is x. The side across from 90, or the hypotenuse, is 2x. The side across from 60, we don't know right now, okay? But we do have two sides labeled, so I'm going to use the Pythagorean theorem. And I'm going to use this Pythagorean theorem to find my missing leg. So I know that one leg is x, so I have x squared. My other leg I don't know, I'm going to leave it as b. I don't know what this one is. This is across from 30, across from 60, don't know. My hypotenuse is 2x. Okay, so then I have x squared plus b squared equals 2x squared. Squaring 2 gives me 4. Squaring x gives me x squared. So 2x squared, I have to both square the number and the variable there. Solving for this unknown side, I don't know this side length. I'd subtract x squared from both sides. So b squared, if I have 4 and I take away 1, I have 3x squared. Okay, so we're getting there. This length, unknown length, we'd have to take the square root, which is just going to leave me with b. Can I take the square root of 3? No, it's not a perfect square, so I'll leave it as the square root of 3. I can take the square root of x squared. It's just x. Now, would you be able to do that on your own? Probably not. This is kind of just discovering why this relationship exists between our 30, 60, 90 triangles. So I have x, 2x, and this missing side we just solved for is x rad 3. Okay, this is our second special right triangle. Where's my first little index card go? This is 45, 45. I'm going to put them side by side. There it is. Okay, so we had this. This is what we did in our warm-up. The other special right is here. Okay, this is what we just found. So our 45, 45, x rad 2. Always the same. If I see a 45-degree angle, this is the pattern I'm using. If I see either a 30 or 60, this is the triangle I'm using, where the relationship between the sides is x rad 3, and 2x for the hypotenuse. This is my hypotenuse on this one. These are my legs. For me, one way that I keep the kind of which one is x rad 2 and which one uses x rad 3, for this one I know two sides are the same, x rad 2 is the other side. For this one I know all three sides are different. It's going to be a rad 3 on this triangle. So that's kind of the piece most students mess up. I don't know if that helps you at all, but kind of making brain connections, that's what I do. Okay. So we want to talk about how do I get from one side to the other and so on. So there's now kind of more possibilities. So how do you get from the short leg, meaning always in my triangle, I didn't do a very good job drawing it shorter. The side across from 30 is x. That's my short length. And then the side across from 60 is longer. If I want to get from the short leg to the hypotenuse, well, what's the relationship between the short leg and the hypotenuse? What am I doing? I'm taking x and I'm multiplying by 2. Exactly. So to get from here to this length here, I multiply by 2. That's not too bad to do. This side is 2x. If I had the hypotenuse, I better drawing this time. If I had 2x and I wanted to get to the short side, which is x, well, then I would just be doing the opposite. I'd be dividing by 2. If I wanted to get from the short leg, which is the side across from 30x, to the long leg, which is the side across from 60, x rad 3, well, how do I get from here to here? I'd take x and I'd multiply by by, from x to x rad 3, I'm multiplying by rad 3. And if I wanted to get from this leg, x rad 3, and get to this short leg, I wanted to go from here to here, and I'd be dividing by rad 3. I cannot jump between the long leg and the hypotenuse, or vice versa. If I have the hypotenuse, I can't just jump from the hypotenuse to the long leg, and I can't just jump from the long leg to the hypotenuse. And what that means is I have to solve for x first. So I can't just go direct substitution from one of those to the other. I need to figure out what x is, and then I can go from there. Yeah,
Are those two little like diagrams to the 3690, 45, and then it's gonna be on flashing somewhere?
these note cards.
Yeah.
We could make these maybe too. That would be helpful. Like we could get some, I have to find some large of these. I can take a picture though too and put them on there, put them on the screen. Okay, so let's try some of these. Flip this page. Now, the way that these diagrams are made, they all look like, in my opinion, 45, 45, 90s. They don't look like 30, 60, 90s. 30, 60, 90s, it's a little, the 30 is a shorter side. But these programs are going to just give us a right triangle and ask you to figure it out. So we are going to know that, and so here's my diagram. It's flipped around, but we're going to use it. Side across from 30 is x. I always kind of start there when I label these 30, 60, 90s. Across from 30 is x, and the hypotenuse is 2x. My other side is the x rad 3. Okay, so first I label my pattern, and I tend to always go 30, hypotenuse, fill in the last side. It's easiest for me. For this one, the side that we are given is x, which is nice because now I'm just plugging in. It means this side is 2 times x, or my hypotenuse would be 2 times 5 is, and I'll yell it at once, 10. Yeah, this side is 10. I'm getting 10 by just plugging in. I know x is 5. I plug it into the pattern. 2 times 5 is 10. I know x is 5. I plug it in here. 5 rad 3. I'm done. I don't even have any cleaning up to do there. If I plug x in, I'm done. I have 5 rad 3. There are my 3 sides. Looking at the second one. Side across from 30. Across from 30 is x. Hypotenuse is 2x. Across from 60 is x rad 3. Now I can't go, we've already talked about, we can't go from this long side to the hypotenuse. But I can pretty easily go from here to here. And so if I know x rad 3 equals 4 rad 3, what does x equal? 4. So now I'm just going to plug that in. If x is 4, this side is just x. This is 4. This side is 2 times x, or 8. Okay, once I know x, I'm going around, I'm just plugging it in to the other sides.
The 4 rad 3, so with 4 rad 3 today?
Yeah. Yeah. I already know this side. I just have to solve for the 2 missing. Okay. Side across from 30 is x. Hypotenuse is 2x. Other side is x rad 3. The side I have is the 2x side. So if 2x equals 12, what does x equal? 6. Now I just take that and I plug it in. So this side is 6, and this side would be 6 rad 3. I'm just plugging x in to both of those sides. Okay, next few are a little more challenging. Because I'm given the side I don't want, but inevitably we're gonna have problems that have it. Notice it flipped. Okay, so up to this point, we had 30 in the corner, now 30s are in the top corner, now 30s in this bottom corner. The side across from 30 is X. So on this diagram, the way this is written, this is my X side. Hypotenuse is 2X, across from 60 is X rad 3. They flipped it around on us. The side that I am given is the X rad 3 side. X rad 3 equals 12. So to solve for X, what do I need to do? Divide by rad 3. And again, we run into this issue that we ran into with our 45, 45, 90s, where I can't leave a rad 3 in the denominator, so I multiply by rad 3 over rad 3. And X would equal 12 rad 3 in the numerator. Rad 3 times rad 3 gives me square root of 9, which is 3. Rad 3 times rad 3 gives me regular 3. And then I can reduce this down to 4 rad 3. That process that we just went through was just saying, I have the X rad 3 side, I need to figure out what X is. X is 4 rad 3. Now that I know what X is, I'm going to plug that in. So this side is just X, it's 4 rad 3. This side is 2 times X. Oh my gosh, we're running out of time. I was like, why is Evan packing up? My goodness, he's anxious. I didn't realize how late it was. Sorry. 2 times 4 is going to give me 8 rad 3. Well, I'm glad we at least got one of these challenging ones in. I was so excited for you to have work one too. All right. So for homework, I just want to point out, I lost it. On your homework packet, this is not just 30, 60, 90. Okay, it's 45, 45, 90. And here's a 30, 60, 90. 45, 45, there's a, so you're using both special right triangles. You have to use both patterns. So I'll take a picture of this and put it in the stream as well. So you have both patterns to look at. And we'll do more with special rights tomorrow. Let me double check